Get to question 34. Question 34 says, what is the most probable quark configuration for the eta particle? This kind of question, what it will do usually is, it'll give you a particle, whether it be an actual particle that we've discovered or a hypothetical particle, maybe we haven't discovered it yet. It'll give you some properties of that particle: charge, baryon number, strangeness, charmness, bottomness, topness. Okay? Together, these properties, these four properties, strangeness, charmness, bottomness, topness, this is known as the flavor of the particle. Flavor. Okay? Kind of like we say flavor of the food is salty, spicy, or something. So the particles have their own flavor. Topness, bottomness. This is charmness. And then this is strangeness. Okay? So, in this case, they're all zero. Possibilities here. You could give us up, down, down. It could give us up, anti-up. It could give us bottom, anti-charm. It could give us down, anti-charm, and it could give us bottom, anti-down. Okay? Or a variety of choices. Or it could even say none of the above. Right? So, what clues are we going to use? Well, one of the important clues that you use here is this one, baryon number. If it says baryon number 0, that means it's not a baryon. It cannot be made up of 3 quarks. Okay? That means this is actually a meson, right? So if baryon number is 0, that means it is a meson. So it's got to be one of these. It has to be made up of 2 quarks. So this can't be the answer, right? The other thing we can now start checking are the flavors. It can't have any top quark, it can't have any bottom quark, it can't have any charm and strange. So this one has a bottom and has a charm quark, it can't have that. This one has a down. This one's okay, but it has a charm quark, so this one is eliminated. This one has both bottom, down is okay, but it has a bottom quark, right? So this one is eliminated. So this one, the only thing left to do is to check its charge. It meets every other requirement. It doesn't have any flavor, and its baryon number is 0. Well, how about its charge? Well, the charge of this is 2/3. The anti-up quark, the charge of it is minus 2/3. The charge is 0. Therefore, it meets the charge requirement. The choice is B. Okay? What if it had said the charge is +1 and the charmness is +1? Let's try something like that. What if this had been a hypothetical particle and it said the charge is 1, baryon number is 0, strangeness is 0, bottomness is 0, topness is 0, charmness is +1. Well, it turns out that the charmness property of the charmed quark is +1. Okay? So, this one, we can't be the answer anymore. Up, anti-up, it doesn't have any charmness, right? This one cannot be the answer. It was bottom, anti-charm. Anti-charm quark, the charmness would be -1. So it says here charmness is +1. So this can't be the answer either. Okay? Well, none of the choices here meet the requirement. So if there was a choice none of the above, we would put none of the above. Okay? How about if you had something like this? Like that. Could that possibly be the answer? Now, bottom, down, anti-down, this still wouldn't be the answer. Could this be the answer? And then let's say there's a choice that says none of the above. Okay, this looks like it might be the answer. The charmness property of the charmed quark is +1, so it meets this. The strangeness is 0, bottomness is 0, topness is 0. The only thing else we have to check is the charge, right? The charge of the anti-down, is +1/3. The charge of the charmed quark is +2/3, right? positive 2/3. What's the charge? Positive 1. It works, right? So it meets the chargeness +1, and it meets the charge, baryon number, everything. So then this would have been the answer D. So depending on the situation, you would check all of the properties. If none of them meet, then you would say none of the above, okay? Now, as it turns out, the actual quark configuration of the eta particle, this is an actual particle, it's relatively complex. If you look it up, it is up, up, plus down, anti-down, plus, and then it has -2 s anti-s. They write it this way. So it gets pretty complicated. So it has a conglomeration of quarks in it for the eta particle. It's a complex form of a meson, right? Up, anti-up. Well, what's the charge of that? 0. Down, anti-down. What's the charge of that? 0. S, anti-s, the charge of that is 0. So it meets the charge, remember, was 0. The baryon number is 0 because you're always canceling each other. The strangeness is 0. This is not strange, this is not strange. S, anti-S, also cancels the strangeness, right? So this is a conglomerate configuration of quarks that still meets the requirements of all of these properties. So there are some hadrons that are a complex configuration of quarks, but for you to guess that, this is hard. You would have to look it up online or some source and to read up on it. But these are just more simplified versions of quark configurations that you can check to see if it meets all of those requirements. Okay? Thank you very much.